let us go ahead with the sentiment analysis part. So sentiment analysis part, what we have to really do is we have used something called as weighted sentiment analysis. So this weighted sentiment analysis will help us find if a given sentence is positive, negative, or neutral in nature. So let us see what weighted sentiment is really about. So weighted belongs to a type of sentiment analysis that is based on lexicons of sentiment related words. In this approach, each of the words in the lexicon is rated as to whether if it is positive, negative, and in many cases, it will also tell how positive and how negative a word is or a sentence is. And below, as we can see, this is the weighted sentiment analysis part. And over here, what I've really done is I've done the word tokenization in order to find the top uh, negative, neutral, or positive words. Same thing is done on sentence as well. So let us first see how the word sentiment analysis looks like. So over here, we have imported sentiment intensity analyzer. So this is the weighted sentiment. This will tell us if a particular word is positive or negative in nature. And we have given a polarity score over here. So what we have done in this piece of code is that we have created three lists, empty lists over here. One is the positive word list, the other is the negative word list, and then we also have the neutral word list over here. And we have given a for loop over here, which mentions that if a word has a compound score greater than or equal to 0.1, then such word gets appended in this positive word list. And if a word has a compound score which is less than equal to minus 0.1, then such words will get appended in the negative word list, and the remaining leftover words and the leftover compound scores will be appended in the neutral word list over here. Okay, and these are the print statements over here, and this statement over here will show all the top 100 positive and 100 negative words. So I've printed it this way. So these are the top positive words. These are the top 100 positive words. So you can see that trust, security, agreement, pretty, charm, all are positive in nature, wonderful, comforting. And but when it comes to negative words, we have printed the top 100 negative words. And as you can see, we have violence, timid, violence, prison, death, and we have like successfully created the top 100 positive words and top negative words over here. And the same thing has been done, but the previous sentiment analysis was based on a word. Now we do the same thing, but now we do it on a sentence. So now we have taken sentence, and as you can see, the same thing has been done over here, and we have the negative score, neutral score, and positive score, and then we also have the compound score over here. So we can again give a threshold value and classify a particular compound score for a sentence if it is positive, negative, or neutral in nature. And we have used the polarity score again, and over here we have created them into a data frame. So this is the text, and this is the negative score of that text, this is the neutral score of the text, and this is the positive score of the text, and then we have the compound score. So we can use this compound score again and give a threshold value and classify a particular text as positive, negative, or neutral. So but before we do that, we can also find out how positive, like we can also find out which sentence among all the 1,000 sentences are highly positive or highly negative or highly neutral in nature. So first thing that we have done is we have selected the most popular sentence using the compound score. So the highest compound score will show us how popular a particular sentence is, and we have arranged this compound score in a descending order. So we have just taken this compound score over here. As you can see, we have sort values, and we have done that by the compound column, and this is how our data frame now looks like. So over here we can see that this sentence over here, I firmly believe this is the highest compound score that a sentence has got. So let us go ahead and print that particular sentence, and this is that sentence. I firmly believe that the Oscar, this sentence has the highest compound score. And in order to find the top positive sentence, the same thing has been done. but instead of taking the compound score, we have taken the positive score over here. So we have arranged this particular column in a descending order, which is nothing but our positive column, and we have done that by using the sort values. And now you can see that the sentences have been arranged in descending order based on this positive score. And then over here we have this text over here, mystery man, which is 161. So this mystery man have got this sentence is the highest positive sentence in this particular data frame. Same thing has been done for the negative sentence. Now we have not taken the positive, but we have taken the negative values, and we have sorted them in the descending order. And these are our negative sentences over here. And over here, as you can see over here, rating this sentence has been printed. And let us check how if this sentence is really negative in nature. So this sentence says rating of do not begin to express how dull, depressing and relentlessly bad this movie is. So this sentence is really negative in nature. And yeah, so let us go ahead and give threshold values and classify a particular sentence as positive, negative or neutral. So we have done the same thing over here, but here we have taken the sentence, and wherever the sentence has a compound score that is greater than equal to 0.5, then such sentences are getting classified as positive. And if a compound score is less than equal to 0, then such sentence will be classified as negative, and the remaining sentences over here will get classified as neutral. And these are our predicted values over here. These are our predicted values. And as you can see, every sentence has been classified as either negative, positive or neutral. So next thing that we do is we have added this particular predictions as a target column. So all these predictions have been saved as a target column, and these are our predicted values now. And as you can see, these are the sentences, and these are the negative scores, neutral scores and positive scores. These are the compound scores, and then in the end, after the calculation and using the threshold value, we have our negative or positive scores over here. And then the remaining columns like the neutral, negative, positive and compound scores have been dropped, and then we are left with only the text column and the target column over here. And for now, we have completed the sentiment analysis. We first cleaned the data. We pre-processed all the data and removed the special characters. And then we used the sentiment analysis, the weighted sentiment analysis, and we gave a compound score. And using a threshold value, we have separated a particular text as if it is negative, positive, or neutral in nature. And let us see here how many positive values and negative values are in our data. So we have used the value underscore counts over here, and this shows us that there are total 568 positive values, 316 are negative values, and 63 neutral values in our data. So the data was actually of 1000 rows. So we have two columns in our data set now. And before we apply machine learning model on this data, what we do is we'll have to label encode this target column, and we do that with the help of a label encoder. And what really a label encoder does is that it converts all the categorical values into numerical ones. And using the label encoder, we have given we have encoded our values now. As you can see, the positive value is now converted to 2, and negative is now represented with 0, and neutral is represented by 1 now. And this is our label encoded data set. And after that, we have done the TF-IDF vectorizer. There is another vectorizer called as count vectorizer. It can be used as well, and we can compare the accuracies of the TF-IDF vectorizer as well as the count vectorizer. For now, we have used the TF-IDF, and what the TF-IDF vectorizer does is that it transforms text to feature vectors which can be used as an input to estimator. So we have done that using the TF-IDF vectorizer. And after vectorizing the text column over here, we have split our data. We have used uh, around 80% of the data for training purpose, and 20% of the data is used for test purpose. And over here we have given a random state which is 40. So what this really does is that, let's say two people use the same random state, uh, then they both are likely to get the same results. And after that, you can see this is our X train shape, X test shape, Y train shape, and Y test shape.